use. Now, not everybody likes to have a whole bunch of formulas just thrown at them, so I do want to briefly explain where most of these come from. So I'm actually going to start down here below with this diagram here, and we'll go back to that table in a minute.
Should we memorize that thing for the table?
The table?
Yeah.
Some of them you will need to memorize, yes. Some of them you'll get off all stations to central. There's other ways around it as well. Ashton?
Can you turn the aircon on, please?
Yes, sure. So using this triangle that is here, I think it was on, I just turned it off.
Oh, it's not on here. It is pretty toasty.
Because you're in here.
Oh, there we go. Using this triangle, using SOHCAHTOA, if I want to find out what sine theta is, here is my theta angle, and sine is opposite over hypotenuse. So the opposite is B, and the hypotenuse is C. We're going to do this for all of them. Cos of theta is adjacent over hypotenuse, which is A over C. And then I could find sec of theta. Remember the third letter in sec is cos, so that means the reciprocal of cos would be C over A. Cosec is the reciprocal of sine, so turn the sine one upside down, would be C over B. Tan theta is opposite over adjacent, so that's going to be B over A. And cot is the reciprocal of tan, so we turn that last one upside down to be A over B. The second column that is there is using the 90 minus theta and doing all of that again. Okay, let's write those down quickly. So cos of 90 minus theta, from that angle, adjacent over hypotenuse, is B over C. Do you want me just to write these down because you know how to do it? Or do you want me to explain each one? You got it? It'll make it faster if I write these ones down. Now, so from using that right angle triangle with those labels, you can see that some things are equal. For example, I'm going to shrink this down so I can compare with my table up above. Sine of theta here is equal to B over C. That's the same thing as cos of 90 minus theta. Those things are equal. And hence we have this formula here. Sine theta is going to be equal to cos of 90 minus theta. And all of the rules that are in this block up here, we call them the complementary rules. And you can go through and pair them all up. So we could do the same thing for cos theta. Cos theta is A over C, and sine of 90 minus theta is A over C. And so you can match them up and you see the ones that are the same. The easy way to remember it is that sine and cos are the complements of each other. So that's why they're in this first box together. And cosec and sec are complements of each other, which is why they're in the second box together. And tan and cot are complements of each other. So if you can remember the ones that work in pairs, if you have 90 minus something, you know which one it turns straight into. So cos of 90 minus theta, you can turn that straight into sine theta. Okay? All right, they're the first set of rules. Also, from the top of the page up here, we have a rule that you probably haven't seen before for tan theta. We're used to seeing tan is equal to opposite over hypotenuse, but what is this sine theta over cos theta business? If I use the letters that I've got down below here, sine theta was B over C, divide that by cos theta, which was A over C, and we're all experts at fractions, so we know that we leave the first fraction, Lachlan, kiss, turn it 2 times, and turn the second fraction upside down to become a C over A. Never going to forget that now, it's all Lachlan. Then we cross out the C's, and we have B over A. Where's my tan down here? Look, here's tan. Tan is equal to B over A. So by putting sine divided by cos, I've shown that I actually do get the same thing as tan. So we need to know this rule here forevermore. Tan is really just sine divided by cos. And if you think about it, that means we really only have two basic trig functions, which is sine and cos. Everything else comes from sine and cos. Cosec, sec, and cot all come from sine, cos, and tan. But tan comes from sine and cos. All right? So the third row here, these ones you hopefully recognize. Cosec is 1 over sine, sec is 1 over cos, and cot is 1 over tan. We talked about those earlier in the topic, but they're in there again for you. Now that we know that tan is sine over cos, cot, which is the reciprocal, means that cot would also be cos over sine. Turn the tan one upside down. So we have that extra rule in there as well. This next big block in here, we've already shown these ones before. These ones come from your all stations to central. ASTC, all stations to central. So 180 minus theta is in our second quadrant. Sine of something in that second quadrant is the same as the sine of the acute reference angle. Remember I was talking about all of those? So all of those ones you can look back to your all stations to central. You don't necessarily have to memorize all of those. And that just leaves us to our bottom row here. These are new and unfamiliar, I know that, but they are very important. Now I'll show you where the first one comes from. If I use my right angle triangle down here, Max, my right angle triangle, and I'm going to use Pythagoras' theorem. Using Pythagoras, I would get a squared plus b squared equals c squared. There's the Pythagoras' theorem that we've all known for a long, long time, right? Now, all of my trig ratios over there on the right, they're all fractions. What I'm going to do is I'm going to divide everything through by c squared. So I'm going to have a squared over c squared plus b squared over c squared, and c squared divided by c squared is equal to 1. Now those fractions that I've made, a over c, I could rewrite that as a over c all squared, and b over c all squared equals 1. Look on the right hand side there. What is a over c? A over c is cos, correct. So that would be cos squared theta. What is b over c? So that's going to be plus sine squared theta, and that's equal to 1. And there I've derived it for you. I'm not expecting you to derive them, but these formulas don't just come from nowhere, okay? This is where they come from. I've shown you how to get this first formula here. Sine squared plus cos squared is equal to 1. And it's the most useful of those three. There is that one because sine and cos are our base trig functions, okay? And sometimes you need to be able to go between sine and cos, and this is the best way to do it. To get the other two formulas that are there, all you do is you divide by sine squared, first of all. So if I were to go, let's divide all of that by sine squared theta, each term. What is sine squared theta divided by sine squared theta? 1. What is cos squared theta over sine squared theta? Yep. And 1, actually, I divide the wrong one. I'm doing the wrong one here. That actually goes to this one. Sine squared divided by sine squared is equal to 1. Cos squared divided by sine squared was cot. Yeah, so there's your 1 plus cot squared. So I'm actually going from here to here. It's going to that one, dividing by sine squared. Okay, because up the top, remember up here, my pink, cos over sine is cot. So there's just squared, so it's cot squared. And 1 over sine squared, sine on the bottom, that's our inverse sine, which is the cosec, which is how you get this one here. If I was to divide, start that from that first formula again and divide everything through by cos squared theta, that is how you get the middle one. Because sine divided by cos makes the tan squared, cos divided by cos makes 1, and 1 over cos makes the sec squared. Okay, so that's where they all come from. To be honest, I usually only memorize that one, and if I need the other two, I usually just divide through to find the other two equations again. Okay, all right, so they're the formulas. Now what we have to do with them over here in our examples, we want to be able to simplify some trig expressions. Okay, so what you want to do, if you look at the first question there, I have sine theta, cot theta. Often the simplest thing to do is to try to break them down into the basic trig functions, which is sine and cos. Okay, so for example, sine theta is already, can't change that to be anything else. But cot, look at your table, what is cot beta equal to? In terms of sine and cos? Cos over sine. So we go times by cos theta over sine theta. Now it's basic fractions work. This sine theta is really sine theta over 1. If I have got a sine theta on the top and a sine theta on the bottom, they're going to cancel out. And all that is left is the cos theta on the top over 1, but I don't need to put the over 1 part there. And that's simplified. That's pretty good, isn't it, to simplify it all down, and it just becomes a cos theta. Okay, so that's it. That's all we're asking you to do for that question. Let's try question 2. Simplify sine of 90 degrees minus beta sec beta. Okay, it doesn't always have to be theta. They could put any Greek letter in there. It just means the angle. You can still use the same formulas, okay? As soon as you see a 90 minus or a 180 minus or any of those kind of the complementary or the supplementary rules that were in that table, you always want to try to change those first using the rules that we have. So have a look at your table again. Sine of 90 minus theta in the complementary rules, what does that turn into? It turns into cos, yes. So sine of 90 minus something will turn into cos of beta, because beta is my angle this time. So cos of beta times by sec of beta. But hang on, sec of beta is not one of my basic trig functions. How can I change that? The third letter is C for cos, which means that is the same as 1 over cos beta. In here we have again cos beta over 1, I'll put the 1 on the bottom there, and the cos betas would cancel out. What's the matter, Jess?
Where did you get cos beta from?
So sine 90 minus theta, so sine up here, that one right there. So sine of 90 minus something turns into cos of that angle. That formula right there. Yeah? Okay, still with me?
Yeah.
This takes practice. It is a new skill, and this is why I wanted to do this before the holidays, is because I wanted to give you guys some time to work on this exercise and make sure you get used to using these rules. There's a lot of rules there, I know that. So you need to practice them. Question 3. We have a square root sign there. It would be nice if we could simplify that, but we can't square root things when there is an addition underneath. Okay, so I'm going to have to simplify underneath that square root sign first. Now, I do have some powers in there, but hopefully you will notice that there is signs in both of them. There's a common factor in there. I could take out a common factor of sine squared out of each of those terms. So, big square root sign, factorising a sine squared theta out the front. It started with sine to the power of 4. If I take 2 of them out, I'm still going to have 2 of them, or sine squared theta, inside. For the second term, the sine squared theta has been taken out the front, and I would have a plus cos squared theta. Does that bracket look familiar?
No.
It says sine squared theta plus cos squared theta. Yeah, good, I'm glad it does for one person. They're squares. Whenever you see squares in there, there was those 3 rules at the bottom of that table that had the squares in them. Sine squared plus cos squared equals 1. Okay, looks really messy there, but it's really just equal to 1. So that is sine squared theta, and that whole bracket is just equal to 1. So sine squared theta times 1 is just sine squared theta. Now that the addition part is gone, Now that the addition part is gone, I have sine squared underneath a square root. A square and a square root, they undo each other, don't they? So square rooting sine squared becomes just sine theta. Try to do one step at a time. Question 4. Question 4 is a prove, Max. When you're asked to prove something, you need to start with one side of the equation and try to simplify it down to get to the other side of the equation. Usually you start with the left-hand side and try to work through to the right-hand side. However, because it's simplifying, you always want to start with the messier side, the one that's going to cancel out and have things happen to it, which in this case is the left-hand side. So write down, you go LHS for left-hand side. I'm only going to take the left-hand side of that equation, which is 1 minus cos theta times 1 plus cos theta. And I will need to simplify it down to try to get to sine squared theta. Now, knowing that it's going to something squared might give you a bit of a tip what to do here. I'm going to have to expand out those brackets, and that's going to give me a cos squared in there as well. Okay? So expanding out the brackets, it's a difference of 2 squares. See how you've got 1 minus cos and 1 plus cos? It's a difference of 2 squares. To expand it, 1 times 1 is 1. Middle 2 terms will cancel out. And minus cos times cos will be minus cos squared of theta. Now, the squared rule that we had was sine squared theta plus cos squared theta is equal to 1. But you also need to be able to rearrange that formula if necessary. I have got 1 minus cos squared theta. If I take this cos squared theta here and move that across there, that's going to give me 1 minus cos squared theta, isn't it? It would give me sine squared theta equals 1 minus cos squared theta. I've moved the cos squared theta across to the other side. So by rearranging that, I know that that is equal to sine squared theta. And that is the right-hand side. So I go equals RHS. And your proof should always finish like that. Left-hand side equals at the start. You do all your working out, and hopefully you end up with the right-hand side. So it should say equals right-hand side. Very occasionally, if it doesn't simplify all the way out like that, you might have to go left-hand side, simplify as much as you can, or if it's not quite equal, then you start with the right-hand side and simplify that, and then maybe you will find that they become equal. But that's quite complicated. That doesn't happen very often. Okay, let's try that again. Here's another one. Question 4, prove. So we know we've got to start with one side and try and get to the other side. So again, let's start with the left-hand side. Left-hand side equals cot x plus tan x. And have a peek at what you're trying to get to, because that can give you some tips on what you should be doing. Over here, I do have cosec and sec, okay? That's not great news. They're not easy things to work with, but they're multiplied together. I know somewhere in my working out, I'm going to have to add those two things together, get a common denominator to be able to push those two things together. And actually fractions, I'm going to be able to turn them into fractions, because each of these things over here can be broken down into sines and coses. Okay, let's do that. What's cot in terms of sine and cos? Look back to your table. Cot. Which one's cot? Not sec. Cos over sine. So that's equal to cos x over sine x. Plus, all right, what is tan in terms of sine and cos? Right at the top of the table. Sine x over cos x. Okay, so there's the two fractions that I was predicting. I know I have to put them together, which means I'm going to need a common denominator. If you've learnt the process, it's still the same for all the fractions that you've ever added in the past. We're just doing it with trigonometry now. So I want to multiply the two denominators together. That's sine x cos x multiplied together. To work out what goes on the top, I'm going to have to multiply the cos x on the bottom with the cos x up the top. We're multiplying diagonally. So cos x times cos x is cos x all squared. And then multiply the other way. Sine x times sine x makes sine squared x. Okay, we're making progress. We've turned it into one fraction. Look at the top. Cos squared x plus sine squared x. All the order doesn't matter. What about sine squared x plus cos squared x? Equals 1. See, it's a good rule, this one. As soon as you see sine squared plus cos squared, you know the top of that is going to be equal to 1. All right, we are almost there. We have to get to our answer over here, both of these are reciprocal functions, aren't they? And that's what these are. Well, I've got 1 over sine and I've got a 1 over cos. If I split those apart, you will see the two reciprocal functions. So let's go 1 over sine x, and that's times by the 1 over cos x. 1 over sine is, put it in the third letter, that's going to be cosec x. And 1 over cos is sec x. And guess what? Look back to our original question. That is the right-hand side. Believe it or not, the reason we need to learn these skills now is so that, especially extension people, you can solve trig equations and things. You need to be able to rearrange them so that you can get stuff like this simplified. Okay, keep going. It takes practice. Oh, you need to, sorry, still copying? It takes practice. Like everything in maths, it takes practice. You can't just watch me do them. You have to do it yourselves, okay? But we're learning the steps. So, are you ready for the question 5 now? Yep. All right, question 5. Here we go again. Prove. As soon as it says prove, I'm going to start with the left-hand side and I'm going to try and get to the right-hand side. So I have got 1 over 1 plus cos x. Now the questions that I've done so far have been fairly standard. I've just been able to just simplify down to sines and causes and use the formulas that are in there. But sometimes there are some little tricks that you need to do as well. This one has a bit of a trick here. So I know that looking at the denominator here on the left-hand side, somehow that's got to become a sine squared. Okay, so that's telling me that's going to have to be that sine squared plus cos squared equals 1 rule is going to have to come into play here, isn't it? To get from somewhere from this to something like that. Okay, now that's going to mean that somewhere I'm going to have to try and square that cos. So here is my little trick. I am going to do something that we normally do in surds. I'm going to multiply by what we would call the conjugate, except for it's not a conjugate because it's not a surd. What I'm going to do is I'm going to multiply that by 1 minus cos x over 1 minus cos x. I'm really only multiplying by 1 because it's the same thing over itself, but by doing that, this denominator is going to expand out with that difference of 2 squares to be 1 minus cos squared x. Okay? So, let's expand. On the top, remember that these are like they're in brackets, just like when we do them with algebra. You're doing 1 times 1, which is 1. 1 times the minus cos x is minus cos x. Look at that, the top is already correct, isn't it, for the right-hand side. For the bottom, again, picture these in brackets, and it's a difference of 2 squares. Expanding that out, 1 times 1 is 1. Cos x times minus cos x is minus cos squared x. Remember back here, I wrote it off the side in orange. Oh, there it is. This one here. Sine squared theta is equal to 1 minus cos squared theta. And I've got it happening here again. So there's my 1 minus cos squared x. It's going to become sine squared x. So it's 1 minus cos x over sine squared x. And that is equal to the right-hand side. Great. One last question. Question 6. Oh, go back. Are you still copying?
Oh, no,
You got it?
I was just panicking.
Okay. So,
Question 6. Eliminate theta from the following pair and describe the graph of the relation that we're going to get from that. Now, we have a sine theta and a cos theta, and we're trying to, it's asking me to get rid of the theta from those equations. It's kind of like some simultaneous equations that we're trying to do here. We're trying to eliminate the theta. The only way I can do that, because it's sine and cos, is with that sine squared theta plus cos squared theta is equal to 1. It's the only way to get those things to disappear. So to do that, I'm going to have to square both of those equations so that I have sine squared and cos squared, right? So let's go x squared. I'm just going to square that first equation. Squaring the right-hand side, 4 squared is 16, and also square the cos. So it's cos squared, not x this time, we're doing theta. Do the same thing for the second equation. Y squared is going to be equal to square the 4, so that's 16, and square the sine, which becomes sine squared theta. Now, I know I'm going to have to add those two things together. So what if, let's do x squared plus y squared. Let's add those two equations together. X squared plus y squared would be the same as the 16 cos squared theta plus the 16 sine squared theta. Does that make sense? Because that plus that is going to be equal to that plus that. Yeah? If I factorize the 16 out of the right-hand side, so leave the x squared plus y squared, factorizing the 16, I get cos squared theta plus sine squared theta. And when I see that, I smile because we know we've been successful. Sine squared theta plus cos squared theta is equal to 1. And instantly my sine theta, my thetas are gone. That whole thing there is just equal to 1, so it no longer needs to be there. And I now have the equation x squared plus y squared equals 16. And it is a circle with a radius of 4. So we go, therefore, it is a circle of radius 4, because it asked me to describe the graph in the question. Okay? Oh, yeah, you can say the center is on the origin as well. Yes, if you want to add that detail in there. Yeah. So we were meant to spend 2 lessons on this exercise, and we got the last period of the term. So I do need you to practice this over the holidays.